Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and before we dive into today's episode, I'd like to remind our listeners to rate our podcast on your favorite platform. Your feedback helps us improve and reach more developers like you. Now, let's get started with our chapter summary on distributed hash tables, or DHTs. Victor, are you ready to wrap up this fascinating topic?
Absolutely, Sheila. I'm excited to summarize what we've learned about DHTs. It's been quite a journey through this fundamental concept in decentralized systems.
Indeed it has. But before we jump into the summary, I have a quiz question for our listeners. Here it is. What popular file-sharing protocol uses DHTs as a key component of its decentralized network? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really makes you think about the practical applications of DHTs in the real world. I'm sure our listeners will be racking their brains trying to figure it out. Let's break it down a bit without giving away the answer. We're looking for a file-sharing protocol, so that narrows it down. And it needs to be decentralized, which is a key characteristic of DHTs. I think this question will help our listeners connect the dots between theory and practice.
Excellent point, Victor. Now, let's start our summary by revisiting the fundamental question. What exactly is a distributed hash table, and why is it so important in decentralized systems?
Great question to kick things off, Sheila. A distributed hash table, or DHT, is a decentralized system for storing and retrieving data. Think of it as a giant, decentralized phone book spread across multiple nodes in a network. Each node is responsible for a portion of the overall data, and they work together to efficiently store and retrieve information without any central authority.
I like that phone book analogy, Victor. So, if I understand correctly, instead of having one massive phone book in a central location, we have many smaller phone books distributed across the network. Is that right?
Exactly, Sheila. And just like how you can quickly find a name in a phone book because it's alphabetized, DHTs use clever algorithms to make data retrieval fast and efficient, even in a distributed system.
That makes sense. Now, can you remind us of the basic operations in a DHT? I believe we covered two main ones.
Certainly. The two fundamental operations in a DHT are put and get. The put operation is used to store data in the DHT. It takes a key-value pair and stores it in the appropriate node or nodes in the network. The get operation retrieves data from the DHT using a given key. These operations allow DHTs to function as a distributed key-value store.
I see. So, if I wanted to store my phone number in our decentralized phone book, I'd use the put operation with my name as the key and my number as the value. And if someone wanted to find my number, they'd use the get operation with my name as the key. Is that a fair comparison?
That's a perfect analogy, Sheila. You've really grasped the concept. Now let's talk about some of the popular DHT algorithms we've discussed. Can you recall any of them?
Well, I remember we talked quite a bit about the Chord algorithm and the Kademlia algorithm. These are used to determine how nodes are organized and how data is distributed in the DHT, right?
Excellent memory, Sheila. Yes, Chord and Kademlia are two of the most well-known DHT algorithms. Chord organizes nodes in a ring structure, while Kademlia uses a tree-like structure. Both aim to efficiently route requests and distribute data across the network. It's worth noting that Kademlia has gained significant popularity due to its use in the BitTorrent network.
Speaking of routing, can you summarize how node discovery and routing work in DHTs? I remember this being a crucial aspect.
Absolutely. Node discovery and routing are indeed critical in DHTs. When a new node joins the network, it needs to find its place and establish connections with other nodes. This often involves a bootstrapping process, where the new node contacts known nodes to get information about the network structure. As for routing, DHTs use clever techniques to efficiently locate data or nodes. Instead of flooding the network with requests, they typically use a multi-hop approach. Each node maintains a routing table with information about other nodes, and requests are forwarded to nodes that are progressively closer to the target in the DHT's logical space. This allows for lookups to be performed in logarithmic time complexity, which is quite impressive for large-scale distributed systems.
That's fascinating, Victor. It sounds like DHTs have to be quite resilient to handle nodes joining and leaving the network. Which brings me to my next question. How do DHTs handle fault tolerance and scalability?
Great question, Sheila. Fault tolerance and scalability are indeed crucial aspects of DHTs. For fault tolerance, DHTs typically employ data replication. This means that each piece of data is stored on multiple nodes. If one node fails, the data can still be retrieved from other nodes. As for scalability, the distributed nature of DHTs allows them to handle large amounts of data and high numbers of nodes quite effectively. As more nodes join the network, the storage and lookup load is distributed among them. The logarithmic time lookup operations we mentioned earlier also contribute to scalability, as they remain efficient even as the network grows larger.
That's really impressive, Victor. It seems like DHTs are a powerful tool for building decentralized systems. Are there any common misunderstandings or pitfalls that developers should be aware of when working with DHTs?
Absolutely, Sheila. One common misunderstanding is that DHTs provide strong consistency guarantees. In reality, most DHT implementations offer eventual consistency, meaning that after an update, it may take some time for all nodes to reflect the change. Developers need to design their applications with this in mind. Another pitfall is underestimating the complexity of network partitions. In a large distributed system, network issues can temporarily split the DHT into separate parts. Handling these situations correctly can be challenging. Lastly, security is a crucial concern. In an open DHT, malicious nodes could potentially join the network and disrupt operations or compromise data integrity. Implementing proper security measures is essential.
Those are important points to keep in mind, Victor. Now, as we wrap up, could you share an interesting fact or anecdote about DHTs?
Certainly. Here's an interesting fact. The concept of DHTs played a crucial role in the development of the original Bitcoin network. While Bitcoin doesn't use a traditional DHT, its peer discovery mechanism was inspired by Kademlia, the DHT algorithm we discussed earlier. This shows how ideas from DHTs have influenced other decentralized technologies beyond just data storage.
That's fascinating, Victor. It really highlights the far-reaching impact of DHTs in the world of decentralized systems. Now, I think it's time to reveal the answer to our quiz question. The popular file-sharing protocol that uses DHTs as a key component of its decentralized network is BitTorrent. BitTorrent uses a DHT to help peers find each other without relying on a central tracker, making the network more resilient and decentralized.
Excellent reveal, Sheila, and it ties in perfectly with what we've discussed about DHTs. BitTorrent's use of DHT technology is a prime example of how these concepts are applied in real-world, widely used systems.
Absolutely, Victor. To summarize our key points, DHTs are decentralized key-value stores that enable efficient data storage and retrieval in peer-to-peer networks. They use clever algorithms like Chord and Kademlia for organizing nodes and routing requests. DHTs offer fault tolerance through data replication and can scale to handle large networks. However, developers need to be aware of consistency models, network partition challenges, and security considerations when working with DHTs.
That's a great summary, Sheila. DHTs truly are a fundamental building block for many decentralized systems, and understanding them is crucial for anyone looking to develop robust, scalable peer-to-peer applications.
Thank you, Victor, for this insightful discussion. And thank you to our listeners for joining us for this chapter summary on distributed hash tables. We hope you found it informative and engaging. Remember to visit crashcasts.com and join our Discord community to continue the conversation. If you're enjoying our content, please consider supporting us on Patreon. Don't forget to subscribe to the podcast and rate us on your favorite platform. Your support helps us create more content like this. Until next time, happy coding.